colleagues, dear friends, first of all, I want to thank the organizers of this symposium for inviting me to give this talk, and thus the opportunity to tell you the unusual story of the beginning of our institute, right before this story will get lost in oblivion. During the war, near Berlin, there were 2 radio stations working for the armed forces at a distance of 200 meters. They had to monitor the airspace on behalf of the Air Force. In December 1943, in one of them, there was Werner Reichardt, 19 years old, doing his service. In the other one, there was Bernhard Hassenstein, aged 21. These 2 met just by chance, each one telling the other was fascinated him. Reichardt was enthusiastic about physics and mathematics, Hassenstein just as enthusiastic of biology. They intensely discussed scientific questions. Eventually, they decided and promised each other, in case they might survive this horrible situation, they would create an institute that had never existed before, at least in Germany, an institute of biology combined with physics. This was their dream and the origin of our institute. By the end of 1944, they lost contact while Reichardt was working on his PhD at the Fritz Haber Institute at the Max Planck Society in Berlin-Dahlem. Hassenstein worked on his thesis at the Max Planck Institute at Wilhelmshaven, trying to understand how insects perceive motion. In 1950, they met again and told each other what they had been doing in the meantime. At the end, Hassenstein convinced Reichardt that it would be worthwhile to work together on the motion perception problem, and in consequence, an intense written exchange between Wilhelmshaven and Dahlem occurred, including occasional visits. When they had finished their PhD, they had to look for new places to continue their work. Hassenstein got a position in Tübingen at the first chair for animal physiology in Germany. But for Reichardt, it was much more difficult. But then 2 scientists came into play who became decisive for the further course of events. The first was Max Delbrück. Max Delbrück, born in Berlin, left Germany in 1937 because the political influence on science had become unbearable to him. Originally, he was a physicist, but Niels Bohr advised him to switch to biology, which he did. As far as I remember, the following sentence comes from him: "Biology is too important to be left to biologists alone." The second was Carl Friedrich Bonhoeffer, brother-in-law of Delbrück, director of the MPI for biophysical chemistry in Göttingen. Bonhoeffer was a chemist, but also fascinated by all sorts of current news about neuroscience. To cut a long story short, the interaction and initiatives of these 2 led to 2 things. First, Reichardt was able to come to Göttingen to continue his research in Bonhoeffer's department. And second, after Bonhoeffer died in 1957, Hassenstein and Reichardt could together come to the MPI of Biology in Tübingen to found the so-called Forschungsgruppe Kybernetik. Leaders have been Werner Reichardt, Bernhard Hassenstein, and Hans Wenking. Wenking was an engineer. He developed electronic equipment not yet available on the market at that time. This group was rather small. 2 postdocs, Karl Götz and Dögevario, and 3 PhD students, Christoph von Kampenhausen, Peter Kunze, and myself. Together, 7 scientists. The postdocs, as well as the PhD students, all achieved top positions in research. But I have to admit, it was much easier at that time than it is now. Because the science scenery expanded considerably after the war. A classmate of mine at the chair of Romanistic in Freiburg wrote in his autobiography, "One could escape a chair at a university in these days at best by suicide." Of course, our work was observed by a scientific advisory board called Curatorium at that time. To the first visit of this board, even the president of the Max Planck Society, Otto Hahn, did not miss to come to Tübingen. He was the first president of the Max Planck Society. Konrad Lorenz also visited our group many times. From the beginning, Reichardt had intensive contacts within the United States. At the MIT at Boston, Francis O. Schmidt, a biophysicist and neurobiologist, has founded a think tank, the Neuroscience Research Program, and Werner was elected as a member. Insofar, it was not surprising that Reichardt was offered a full professorship to Caltech in Pasadena as early as 1960. The MIT in Boston, as well as the Bell Laboratories, also expressed their interest in him. Of course, thereupon the directors of the MPI for biology, including Alfred Kühn and Georg Melchers, asked the Max Planck Society for the appointment of Reichardt as a scientific member and director of their institute. From 1960 onwards, the Reichardt department was established in the MPI for biology. At the same time, Hassenstein had received a call to the chair of zoology in Freiburg. After intense discussions with Reichardt, he decided to accept this call and to leave Tübingen. During the next few years, the Reichardt department grew in terms of co-workers. He got a new building and worked in various fields. For example, in the pupil control circuit, on the human retina, in the motion vision of bees and flies, and mechanoreceptors in insects. Even the complex eye of the horseshoe crab limulus was investigated, as well as the reaction to light from the slime mold Trichomyces. We learned from Werner after a few years, the directors of the MPI for biology came to the conclusion that the Reichardt department had become so large and thematically far away from the other departments, so a separate institute would make sense. In the meantime, Dögevario had been appointed to a chair in biocybernetics at the University of Tübingen. And we always had a close cooperation with him, for instance, with respect to PhD students. When he was away for a sabbatical, we replaced him at the university. Over the years, Werner had, of course, discussed with Karl Götz and me about our future. And he told us that he wanted to appoint us as co-directors in the new institute. In this context, from now on, we consider to focus on one topic, to study the processing of visual information in insects, and this on different levels, such as behavior analysis, signal flow within the brain, And of course, we had to know the optics of the eye in detail, that is, its resolution, and also how light is transformed into electrical neuronal signals after its absorption in photoreceptors. Werner, Carl, and I could work on these problems, but there remained one area where we had no competence. We also needed to know the structures of the brain in which the information processing takes place and generates behavior. Werner knew Valentino Breitenberg, an anatomist from the Cybernetics Institute of Naples, so he proposed him for appointment as a fourth director. With these four directors, the institute was founded in the year 1968. I will not talk about scientific matters now, as everyone can read our papers on our homepage. Instead, I will illustrate with some examples how life was pulsating in our institute half a century ago. The most important question, how could it be that Werner succeeded to found a new MPI? Ja, nee, halt, das kommt als nächstes. For me, it's clear it's by no means sufficient to be an excellent scientist. However, you have to be able to convince people of the importance of what you are doing. And Werner was indeed able to convince people. Not so much in his lectures. Sometimes it was even not so easy to follow his red line. However, in personal conversation, even during small talk at a bar. Another characteristic of Werner, he could also be somewhat aggressive. Once he had a dispute with Valentin. I have forgotten why. He then, at an institute meeting, let the whole institute know what his opinion was about Valentin. It took months for them to reconcile. He also could be very clear in this sense in academic committees. Werner was also able to celebrate playful, for example, at institute festivals. He played the piano, nothing classical, but Berlin bar music. As a student, he had to make money with it. To mention one more of his qualities, he could be wonderfully self-ironic. His written English was really good, but he had quite a strong accent, at least in the early years. Once he came back from New York and told us. On his way to the train, he asked the bus driver, "Please, can you tell me the next way to the main station?" The bus driver replied, "I'm sorry, but I don't speak any German." Now to events of considerable relevance to all of us. Every 2 or 3 years, the whole neuroscene of that time gathered here in Tübingen. I happened to find a program of the 1966 Symposium. It was a symposium on processing of data by the visual system. You will see there were several Nobel laureates. However, all of them got their prize after this conference. Here is Werner together with William Rushton, a fellow of the famous Trinity College at Cambridge, and Sir Bernard Katz, University College London. You can see they are sitting on the terrace of the Max Planck House. The Max Planck House was a wonderful place for such events. Here you see Tommy Poggio and Peter Kunze, both are here now, PhD students of the Forschungsgruppe. This is Thorsten Wiesel from Harvard Medical School. And in the last photograph of this series, you see here Keffer Hartline from Rockefeller Institute, New York. Two of the Nobel laureates became of particular importance to our institute. So Bernhard Katz, born in Leipzig, he had to leave Germany in 1935 because he was Jewish. For the first time after the war, he came back to Germany to visit Werner Reichardt. He knew that Werner was in the resistance against the Nazi regime and was sentenced to death. Katz became a member of our scientific advisory board called Curatorium at the time and remained so for many years. The second Nobel laureate with whom he had close contact was Keffer Hartline from the Rockefeller University of New York. Hartline had discovered that in the compound eye of the horseshoe crab Limulus, there was a network of neurons where signals generated by light stimuli mutually inhibited each other in a particular way. He proved this by illuminating small areas of the eye and recording the electrical activity in the neurons of the optic nerve. Reichardt recognized the possibility to generalize his results in the following sense. It must be possible to formulate equations to calculate the distribution of activity in the optic nerve for any optical pattern and present it at any distance from the eye. To allow this, adequate experiments had to be done in order to determine the parameters of these equations. Reichardt explained our plans to Hartline and then sent me to him in order to learn the technique developed by Hartline. For me, as a young postdoc, it was an unforgettable experience to be lucky to work for 2 weeks in this famous laboratory. From then on, of course, we maintained our contact with Hartline and his co-workers. Thereupon, I installed seawater tanks in the institute and imported Limulus from Woodsole. At the airport in Stuttgart, I had to explain to the veterinarian what kind of animals horseshoe crabs are, and I had to sign a document stating that the animals cannot escape from our lab and contaminate our rivers and lakes. Actually, it's a pity that they didn't. One other aspect. From the 1980s onwards, the neural scene in Tübingen University began to develop more and more. In this context, neuroscientists of Tübingen applied for money of the German Research Foundation. Of course, the university invited us to participate. However, Reichardt was not interested, with the argument that we do not need additional money. But he accepted my argument that our young scientists need to apply for money, not because of the money, of course, but only if they apply for money, their papers will be read by reviewers, and these reviewers are filling university chairs. After all, in 1958, a special research area, a so-called Sonderforschungsbereich, was founded. Neurobiological aspects of behavior. It existed until 1999. I don't show the board of directors here because these directors you probably don't know. I show it that you can see that quite a number of clinics and other institutes of the university participated. Members of the projects met every year for a conference in a building of the university at Blaubeuren, close to Ulm. And in so far, all of us knew what happened in other areas of the neural scene in Tübingen. I just want to mention that somewhat later, one more SFB was founded, cellular mechanisms of sensory processes to which we also contributed. Let us now compare our former institute with the one we have today. First, concerning the size of the institute. Every director had 4 postdoc positions and 5 PhD students, which means we had been some 40 scientists. As I learned from Reichardt, there are now 200 scientists. That is about 5 times as many as before. And what about our research cost? The investigation of motion perception in insects was of crucial importance for establishing our institute. A beetle will follow the rotation when a cylinder with vertical stripes is rotating around him. To analyze this reaction, it is necessary to quantify it. To do so, Hassenstein developed an ingenious method, the so-called Y-maze globe. The beetle was fixed, but still able to walk on the Y-maze globe. Again and again, he came to a Y, where he had to choose either right or left. The ratio of right to left choices is a measure of the response strength. The Y-maze globe was made of straw stripes glued together in a particular way. The straw was for free, but glue had to be paid for. Next, you can see a typical research device at the institute of today. You can see there is quite a difference in cost. One other aspect. As we know, inventions are sometimes named after their inventor. Everybody knows what a Geiger counter is. It allows to detect radioactivity. By the way, Hans Geiger was a professor here in Tübingen. That's why we have a small footpath here called Hans Geiger Weg. If Geiger's work had belonged to the so-called humanities, we certainly had a Hans Geiger Street. But for natural sciences, obviously a path is okay. But does everybody know what a Reichardt detector is? You find it with Google. Here you see the detector, the result of the analysis of motion perception in the beetle Chlorophanes by Hassenstein and Reichardt. As you can see, there are filters modifying the signals, but signals are also multiplied with each other. It's not quite fair that it is named after Reichardt alone. It should be called Hassenstein-Reichardt detector. But Reichardt published a paper, autocorrelation, a principle for evaluation of sensory information by the central nervous system. Autocorrelation is accomplished by this detector, and this paper made the detector famous, and therefore Hassenstein is not mentioned. The detector provides the minimally necessary processing of information for the motion vision in this insect, but it's also sufficient to explain the results. But it does not tell anything on how the individual elements are realized within the nervous system. This will be the topic of the talk by Alexander Borst. A special event was, of course, when Werner Reichardt was awarded the Order pour le Mérite in 1980. The order was founded in 1740 by Frederick the Great. In 1952, the President Theodor Heuss of Germany, our first president, re-established the Order pour le Mérite for Sciences and Art. There are 40 domestic order holders. As far as I know, German Nobel laureates received the order in principle. Werner was probably proposed by a member of the order. Werner retired in 1992. For his farewell party in September 92, he invited co-workers and friends to an Italian restaurant in the old town Al Dente. It was planned that a friend of his, Gunther Sten from Caltech, would give a laudatio for Werner. But then something unexpected happened. Valentin Breitenberg came to my wife and said, Werner is unwell. If you could look after him. He knew that my wife is anesthetist.
Audio will resume shortly.
That was held. We then had to learn that Werner had suffered a severe stroke from which he died a few days later. Werner was buried in the cemetery of one of the Tübingen hills. 20 years later, the graves are usually removed after short notice from the city. Surprisingly, however, the municipal official responsible for the cemetery, Bernd Walter, called our administration, Reichardt. In view of the importance of Werner Reichardt, he would find it a pity if the gravestone was removed, but the tomb could not be preserved. And so Reichardt's tombstone was erected outside the grove area as a memorial stone. And the following text was placed on the stone. Werner Reichardt war 1968 der Gründungsdirektor des Max-Planck-Instituts für biologische Kybernetik und Namensgeber für das 2007 gegründete Werner-Reichardt-Zentrum für integrative Neurowissenschaften der Universität Tübingen. In Gedenken an seine Verdienste, die Max-Planck-Gesellschaft und die Universität Tübingen. I would like to add, to some extent, the roots of our so-called Cyber Valley go back to Werner too, insofar as our institute called Bernhard Völkop as a director and convinced him to come to Tübingen. Werner retired in 1992, Valentin Breitenberg in 1994. Because Karl Götz and I retired many years later, we were entitled to request appointments for two new directors. We had to take into account, of course, that this would determine the research direction of the Institute for the next decades. In fact, the focus of research for Valentin and for myself had already shifted from insects to vertebrates and humans. Therefore, we were looking for scientists in this field. We realized that a particular research area which had come from Germany, this Weber and Fechner, was not longer represented in Germany. Psychophysics, today being a part of cognitive sciences. It was not difficult to find an excellent psychophysicist, Heinrich Bülthoff. He did his PhD here with us in Tübingen and stayed here for 5 years. Then he left to the United States, switched off from insect research, and became professor for cognitive sciences at Brown University in Providence in 1988. We were happy that he accepted the call as a director here in 1992. Of course, we also looked for a neurophysiologist. I knew Nikos Logothetis from literature. We were happy first that the Max Planck Society was willing to provide the high cost necessary for his appointment, and second, that he was willing to come to Tübingen. So in 1997, Nikos Logothetis became here a director. What we could not have foreseen was that the animal protection activists would succeed in destroying this most successful line of research in our institute. In 2021, Nikos Logothetis left our institute with several of his co-workers and went to an institute in Shanghai in China. Logothetis has introduced magnetic resonance imaging here, and as you know, a large department of magnetic resonance technology is still active here under the direction of Klaus Scheffler. Finally, theory should also be represented by the Institute. We thought, of course, of Tommy Poggio, but Tommy did not want to come back to the Tübingen province. However, Heinrich Bülthoff knew Bernhard Schölkopf, who was to complete the second generation of Institute directors in 2022. Many of you know what happened later, but this is not the topic of my talk. Thank you for your attention.